Okay, let's take a moment talking about intercellular junctions or how cells attach to each other. These attachments are how all epithelial cells connect to each other, so they're super important for epithelium. But they're also important because some muscle cells also connect to each other with these attachments, and sometimes neurons do as well. So I'll talk specifically about those as I go through the different types of attachments. And there are three different types of attachments, which you can see here on the right side. So we got two yellow cells here. The uppermost, excuse me, excuse me. The uppermost one shown is known as a tight junction in English, the zona occludens in Latin. The second one, which looks like it has a zipper in the middle and then it's got little things coming out into the cells, in English is called an anchoring junction, also known as a desmosome. And the one at the bottom, which looks like kind of has a straw connecting the two cells, or a flower thing with a straw, is known as a gap junction. So let's go through them one by one. The tight junction is important because it is a barrier to diffusion. Even water cannot get through a tight junction. When you look at a tight junction, look at the bottom right where we have the plasma membrane of one cell that has transmembrane proteins, and the adjacent cell also has transmembrane proteins. And then think about putting super glue and attaching those two transmembrane proteins to each other, and nothing can get through that. Okay. And as you can see, we have rows of these right near the apical surface of the cell. So we have these and epithelium in rows and rows and rows of them near the apical surface, so that whatever is here in the lumen cannot squeeze between the cells to get at the tissue that is deep to the epithelium. So it's preventing molecules from passing between the cells. So we find these in intestines and in kidney tubules. And you're going, so is this a good thing or is this a bad thing? Well, it's a little bit of both. Because if you think about in your intestines, you're eating proteins, you're eating carbs, you're eating lipids, you've got amino acids, you've got fatty acids, you've got sugars. You want those to go into your bloodstream. They're stuck here in the lumen. How do they get to the blood vessels that are down here? Because remember, the epithelium is avascular. There's no blood vessels up there. It's got to get down below into the tissue. Well, what that means is it has to go into the epithelial cells. And that requires energy. It's going to have to go into the cell and then come back out of the cell. And if you're a nursing student, you're going to learn all about this when you take human physiology. All right. The second type of intercellular junction is the anchoring junction or the desmosome. And its purpose is not to prevent stuff from moving between cells, but to distribute stress between throughout the cell. So like I said on the first slide, this is one that looks like it has a zipper that connects the two cells. And we all know we've had zippers that have busted. So in addition to the zipper connecting the two cells, you can see we have this big protein from which we have these filaments, which are keratin filaments. And you can see there's lots and lots and lots of keratin filaments that are extending from this area, and they go to a different area of the cell, like to the basal area or all the way to a different area. And they are like the guy wires that you see going from telephone poles and anchoring into the ground. So that if you are pulling on this zipper area, you are really tugging at this area instead. And so it keeps those cells from being pulled apart. So we're going to find these desmosomes or anchoring junctions in areas that have high mechanical stress. So yes, your skin. So when you're rubbing on your skin cells, they're not pulling apart from each other. But another place that has a lot of mechanical stress are your heart cells, as you can imagine. Very important, especially because those heart cells are branched. We want them to stay attached to each other. And so they're going to have desmosomes anchoring them to each other. So think of this. We've got a zipper and we throw an anchor to hold it to other cells. The third type of intercellular junction is a gap junction, which gives us a transmural protein channel. Okay, and so it looks like a little flower on one side. You can clearly see the channel, and the channel of one transmural protein lines up exactly with the channel of the adjacent cell's transmural proteins. And what this allows is ions, potassium, sodium, simple sugars, and very small regulatory proteins, whatever is in one cell, to almost immediately pass into the next cell, going down a concentration gradient. Okay. And here you can see dozens of them. And we have these in cardiac muscle as well as smooth muscle. Do you remember when we were looking at cardiac muscle and we saw those dark lines, those intercalated discs? Those dark lines were because we had hundreds of gap junctions all lined up in that little area. And when we learn about the heart muscle, you'll understand why that is so important for cardiac conductions. All right. Then there's something else called a hemidesmosome. So if you go back and you look at those different cells, remember we had a gap junction, then we had an anchoring junction. Sorry, we had tight junction, then we had an anchoring junction, and then we had a gap junction. If we go back to the anchoring junction or the desmosome, and we take the prefix hemi, which means half of that, that's what a hemidesmosomes. And hemidesmosomes are down here at the basal surface, and they are found on epithelial cells. So if you remember, I told you epithelium is attached to tissues from the basement membrane. So here we have half of a desmosome. So we've got half of that zipper, we've got that plaque, and we've got those keratin things which are going to come and anchor it. And so that zipper is going to attach to protein fibers, which are found in that basement membrane. And then the keratin filaments are going to attach to other places in the epithelium to help resist the forces, which will keep the epithelial cells from pulling off the deeper tissues. So the anchoring, the desmosomes keep the cells together, and the hemidesmosomes keep the cells attached to the basement membrane. So, see how he's holding on for dear life? Is that how you feel? Hold on for dear life to all this information. If you understand it, then we can continue to build onto it. And you're doing great. We're going to come back. We only have one more video for today. Thank you for all your hard work, and I'll see you shortly.